Lesson 15.4 is derivatives and integrals with transcendentals. So basically it's mixing up and teaching your brain how to go from integrals, which is antiderivative, to derivative, which are undoing each other essentially. So I've got the basic antiderivative rules that we've talked about, plus one that we haven't done so far in this unit. And then we're going to do derivative rules on the second four of them. And so we need to know that if we have a number raised to the x power, it's called an exponential function. It's that same exponential function divided by the natural log of the base number. The other thing that applies here is still that chain rule, or really the opposite of the chain rule, is if we ever have something times our x, we're dividing by that number or multiplying by the reciprocal. Also, these are not specific bounds. We don't have an a and a b value, so we have to add the plus constant, plus c. If you don't add the plus c on these, you will get it wrong. So always double check that you've done that, because we don't know if there was something here that when we took the derivative of it, made it go away and not show up. Okay, the second one was the e to the x. Remember that derivative and antiderivative of e to the x stays e to the x. But again, if it's something times x, then we have to do the chain rule, plus c. Then if we have a reciprocal or a rational function, 1 over a denominator with x, that's natural log of the absolute value of x, plus c. So it's kind of mixing all the rules together. So I kind of have to talk myself through this and think of each piece, what do I have? Like on number 1, I see a number to an x power. So I'm going to use this rule, which says that the antiderivative is that exponent divided by natural log of the base, which is 3. I do not have anything times x, so there's nothing to divide by. Plus, I see 1 over e to the x. You could treat this as a reciprocal function, kinda. No, actually you couldn't, because we need it to be like a polynomial in the denominator. This needs to be changed to where you float the e to the x up and make it negative x. We can't have an exponential in a rational function. So really this is e to the negative x. So what I do there is e to the x is itself. So I keep it the same, but then I divide by the negative 1, which is the same thing as multiplying by negative 1. And then don't forget your plus c. You can put it in exactly like that. So the good thing is there's not a lot of simplifying on these. Bad thing is they're kind of a pain to type in your answers. All right, number 2, we're going to antiderive e to the 3t power. E is a number, so that it actually fits this again. So we'll have e to the 3t divided by, so I guess I should say this. You could divide by natural log of your base, which is e. Well, natural log of e, we've talked about, is just 1. So that's why you don't have to do that. So actually, let me back up and say, well, this is an e to the power rule. So it's itself, but since it's 3 times x or 3 times t, we need to divide by 3 or take it times a third. Plus, then I see a rational function, which fits this rule. So it's natural log of the denominator, 4 plus 3t. But since there's 3 times t, I need to divide by 3 or take it times a third. And don't forget your plus c. Number 3, e to a power. E is a constant. Think of like if we had 2 to the 3rd power. So if I have something, or let's just even say 10, if I antiderive that, I have to tag an x onto it. So this constant gets an x. It's kind of hard to think about because e kind of freaks us out, but it's a constant, so you have to add an x, just like if it were a number. And then this is another a rational function, so it would be times the natural log of the absolute value of 3 minus x, but then I have to divide by negative 1 or multiply by negative 1 plus c. Last one of these, we've got pi, which is a number, to the x over 2. Think about that as pi to the 1/2 x power. Oh my goodness, not pi power. So since it's a number to a power, that fits this rule. So we're going to have that same exponent on top divided by natural log of the base, which is pi, but because our x is times a half, we're going to divide by a half or multiply by 2. You can put in front of the fraction or float it up with the numerator. Plus, and then I've got another rational function, natural log, the absolute value of 6 plus 3x, divide by 3 or multiply by a third, and don't forget your plus c. So those are antiderivative rules. Now switch your brain back to thinking regular old derivative. So remember that when we have just a number, that goes away. And then if we have something that's x to a power, we bring that number in front and then subtract 1 from the power. So think antiderivative is adding to the power and dividing. Derivative was back to multiplying or bringing the number in front and then subtracting. So it's just all the opposite. So number 5, 3 to the e power. 3 is a number, e is a number. So I could do that on a calculator and get a value, even though it's going to be irrational, that's still a number. So any constant, just say that's 19.8, any constant goes away when I take the derivative. It always like decreases a power. So that's gone. I'm going to fix this 2 over t to be 2t to the negative first power. So remember, we bring that in front or multiply. 2 times negative 1, so that's negative 2t, and then we subtract 1 from the power, so that would be to the negative second power. You could fix that and float the t to the bottom, so it'd be negative 2 over t squared. So you really have to talk yourself through e and pi, and whether you have exponential, all that kind of stuff. So the next one, derivative of 2 to the e power, just like on number 5, 2 to the e power is an irrational number, but either way, it's a constant. So when I take the derivative of it, it goes away. X to the pi. X is the base, so that's having this to a number. Pi is a number, so it's bringing pi in front of x and then taking pi minus 1. Doesn't look very pretty, but that's what it is. All right, number 7. I don't want to keep this 1 over something because I don't see any rules here. Don't get confused with this. I don't see a rule here. I see that I could take the derivative of natural log of x. So what I want to do is rewrite this so that it's 5 plus 3x, bring it to the top so it's negative first power plus pi to the x. So then I bring the negative 1 in front, and then I subtract 1 from the power, so now it's to the negative second. Pi to the x is having a base that's a number. So that would be like here, a number to the x power is going to be plus itself times the natural log of the base, which is pi. You could fix this and drop this down to the denominator and make it squared, but you shouldn't have to. That should be your answer. All right, and then last one, e to the 1/2 x is how I'm going to rewrite that. So this is a base of e. Remember, the derivative of e is itself, but now instead of dividing by 1/2, I'm multiplying by that derivative 1/2. 2 to the x fits this rule. It's a number to an x power, so that's going to be plus itself times the natural log of the base, which is 2. So this will be good for hopefully helping you switch your brain back and forth between the rules.